the AI for Good Global Summit aims to bring together industry leaders to try and harness AI to further the UN's development goals in areas like health, climate and sustainability.
How do we govern technologies if we don't yet know their full potential?
The main purpose of this summit is to explore how the AI solutions can help sustainable development.
AI will come to influence almost every aspect of our societies and economies.
AI 这里框架
AI for good.
I would say the most pressing topic at the summit is going to be how do you handle deepfakes, misinformation.
成为 AI for good 的
Cumbre Mundial All for Good.
The good news is that the future of undetectable deepfakes can be avoided through the development and implementation of robust detection technologies and international standards.
What I've really seen is the fact that we can really affect amazing change, but we have to do this together and we have to do it in collaboration with partners, with organizations, with institutions, and that's what's making me so excited about what AI for Good is all about.
One-third of humanity remains completely offline, excluded from the AI revolution.
Artificial intelligence is changing our world and our lives, and it can turbocharge sustainable development.
We are the AI generation, and this is our moment, and it's our responsibility to write the next chapter in the great story of humanity and technology.
Welcome to AI for Good, the leading action-oriented, global and inclusive United Nations platform on AI. Organized by ITU, in partnership with 40 UN sister organizations, and co-convened with Switzerland. The goal of AI for Good is to identify practical applications of AI to advance the United Nations Sustainable Development Goals and scale those solutions for global impact. In today's session, we're counting on you to use the live video wall feature to ask questions and post comments to help create an engaging discussion. We encourage you to stay until the end to chat, connect, ask questions, and network with our distinguished panelists and world-class AI experts in the neural network. It is now time to kick off the session and welcome our first speaker. The floor is yours.
Hello, everyone. I warmly welcome you to our webinar today on AI and sustainable urbanization for good on behalf of the organizers, the Seoul Institute, Luxembourg Institute of Socio-Economic Research, and the Korea Planning Association. I'm Eun-kyung Kim from Luxembourg Institute of Socio-Economic Research. I will be chairing today's session. As cities face increasingly complex challenges, AI emerges as a powerful tool for enhancing urban planning and decision-making. Today's webinar brings together distinguished experts who will explore various dimensions of AI and its role in creating sustainable urban futures. Before we begin, I'd like to invite Dr. Junyoung Choi from the Seoul Institute to outline our workshop's objectives and future directions. Dr. Junyoung Choi, please proceed with your opening remarks.
Thank you for introducing Dr. Eun-kyung Kim. I'm Junyoung Choi, and I'm working at the Seoul Institute as a director of external collaborative research. Last 1 year, we are organizing this event with not just the planning, but the mobility and the environment and every aspect of urban planning and urban built environment issues. So this webinar is organized with the two partner organizations, Seoul Institute and Luxembourg Institute of Socio-Economic Research and Korea Planning Association. We hope to continue this kind of the technology and the urbanization issue and the more continue to dealing with the issues in the next other events also. Thank you.
Okay, so I'd like to introduce today's program. Our program today reflects the multifaceted nature of AI in urban development, bringing together experts from research institutes, universities, and industry across the world. We will explore how AI is transforming cities through four key perspectives: strategic planning for megacities, optimization of urban mobility systems, environmental resilience through satellite technology, and the critical frameworks needed for responsible AI governance. These interconnected themes will help us understand both the practical applications and policy implications of AI in creating sustainable urban futures. Our discussion will be enhanced by perspectives from experts in spatial, geospatial analytics and urban design, helping us exploring the practical implications of these developments. And I'd like to happy to introduce our first speaker, Dr. Junyoung Choi from the Seoul Institute. As a director and a research fellow at the Center for Collaborative Research, he brings extensive experience in smart city planning and e-government initiatives. His work focuses on AI and XR-based decision support systems, and he has contributed to numerous national projects on spatial policy and urban development. Dr. Choi will share insights on digital technology for megacity planning with a particular focus on artificial intelligence in planning. Dr. Choi, please proceed with your presentation.
Yes. Yes, thank you for introducing. My presentation is about AI, artificial intelligence for mega city planning. My presentation is 5 sub-chapters from planning issue to digital technology in the AI era. The Seoul Institute, before starting the presentation, I would like to introduce my research institution. The Seoul Institute, established in 1922 and fully funded by Seoul Metropolitan Government, and 6 research division, 1 AI lab and 1 center, and 300 researchers, and the budget is about 37 million US dollar. The planning issue in the metropolitan area is a kind of the expansion of urban area, built environment over administrative boundary. In case of Seoul is surrounded by Gyeonggi and Incheon, and it consists Seoul metropolitan area, mega city region, and it expanded from very rapidly from the early 1960s, and from 1980s and 2010 is most of the area is urbanized, and as of 2019 it is commuting from the very long distance, so long distance time and long travel distance. So in this the metropolitan area, there are many issues, increasing urban problem over inside, not just inside, but in between the administrative boundaries. such as regional transportation, conflict of waste management installment, deregulating the green belt for housing provision, regional mass transportation service, common use of water resources, and NIMBY issues that need to deal with this kind of issues. We have a complex and integrated decision making. So Seoul metropolitan area, we deal with these issues. We have setting up some vision and objectives, such as competitiveness, industrial space, citizen needs for culture and climate change, and it also some kind of integrated and complex decision-making process. Planning and planners naturally basically needs a wise investment of limited public resources and management of the complexity of human settlements, combining quantitative and qualitative information for optimal decision making. So planning through rational models, processes, and participation strategies, evaluation of planning tools from statistical techniques to map-based suitability analysis, traffic models, and digital twins. But the role of AI and planning decision making, that is, as a automated decision making tool, AI operates as an artificial intelligence capable of making decisions without explicit human command, and it it predicts behavior outcomes based on patterns identified from accurate data and rules. But the interpretation and response to unintended outcomes and unexpected errors. So there's some good outcomes, and we need to very cautious of outcomes when applying or using AI in planning processes. There are many elements of AI element in urban planning and design, from machine learning, deep learning, neural network to real-time emotion analytics, thought control gaming, real-time universal translation to virtual personal assistance. So the the reference depicted this diagram. There is more than 100 components of artificial intelligence that currently impacting planning and urban design practices. So we have to need to consider the implication of AI usage in urban planning. There are synergies and similarities between AI and planning. The essence of planners is creativity and human-centeredness, and AI cannot replace the metaphors of expression and style that plannings bring. AI should be used as augmented intelligence. But the rapid development of generative AI technology is exceeding previous expectations. So implication of AI in urban planning, that is the technical accuracy of AI models and the limitations in available data, the need for literacy in automating qualitative aspect into numbers and entities within software code, discovery of best practices, collaboration with engineers, and AI literacy for planners. So the use of AI for planners is somewhere between creativity and humanity. You may heard about the deep blue in chess, the 1997 expert system by IBM that is compete against the human chess champion Garry Kasparov. But listen to AlphaGo in Go, developed by DeepMind in 2016, artificial intelligence developed by DeepMind, which competed against the human Go champion Lee Sedol. The creativity, we think creativity comes from the the 37th move played by DeepMind in its second match against Lisedol. Someone told this is a kind of creativity, but this is creativity. Then the computer or AI it is a triumph over human creativity. So the technology, in terms of technology, it developed from big data plus AI that enhancing analytical capability, that expanding the target and scope of analysis, to AI plus robotics that focused on automation, replacing human, physical, and emotional labor, and generative AI. This is decision-making support and reduce times and cost of information search and acquisition, but rapidly developing. So we need some creativity to control and this kind of technology in the planning field. So the problem solving with complex and integrated thinking for planning, for megacity planning, that means if necessary data such as population, land use demand, facility demand, and market policies are sufficiently studied, won't it be possible to support the establishment of urban planning? Some expert in the Korean expert, he talked about the last ability left to humans. That is the attitude, last capability of a human. That means the knowledge being replaced or removed, eliminated by generative AI, technology replaced by AI-powered robots. So we think about the planning process, decision-making process of planning and design. So as to we use AI, adaptive use of AI as a planning tool, and we also consider enhanced planning and design workflow. So the step is from the briefing example to completion, or from fully digitalized planning and urban design service workflow to high adaptation to high design support, AI augmentation to design process. That means we consider planning process enhanced or adapted with or inside AI tools for planning. There are some strengths and weaknesses of AI as a planning tool. That is technology, and in terms of technology and planning, such as spreadsheet, statistical packages, and GIS already enhance the efficiency of planning tasks by automating, but need for evaluation to assess the relative strengths and weaknesses of AI tools when applying this already the changing this technology into AI, such as ChatGPT. And also we need to consider tame and wicked problems. The potential of AI is recognized, but its development is limited by a lack of data on urban spaces and processes. And also other kind of issues, such as data issues. We need to deal with spatial phenomena. So we are developing or planning process inside not just 2D space, but also 3D space. But there is limitation and also opportunities for the use of 2D and 3D spatial information in application field. So as AI as a planning tool, the goal of planning is to strive for the common good, while AI can address problems that humans cannot solve alone. So planners refer to ethical guideline in their responsibility, whereas AI lacks an ethical framework. So we count on values and ethical decision making. The topics include the ethical handling of data, moral decisions, or ethical algorithms. And also we consider inclusiveness and transparency. When AI makes decisions based on data sets, people not represented in the data may be excluded. Incomplete data sets can lead to inequality, and algorithm bias can exacerbate disparities. As a users of AI, planners need to understand the sources of data, who is represented in the data, and what is represented and absent in the black box. AI literacy is a key for planners to use AI fairly and convey its purpose. In the AI era, digital technology and the planning process, we also use geospatial data from the 2000 in Seoul in the urban planning committee. Also 2022, we use 3D dimension, but the planning process itself is still the same, but with more detailed data sets, but we need to consider more planning process into this virtual space. So inside the virtual space, we need the interactions between humans, NPC, non-player character is the main kind of NPCs interaction, and we can make a virtual environment very similar or can be a norm for the human behavior, and it can be used as a guideline for the other decision-making process. So in the virtual space, digital space, we make or try or test the many policy interventions, and policy simulation cannot be done in the physical world. In the near future, the rapid development of digital twin technology, it is photorealistic and very impacting what is the impacting the development and how people or citizens can interact in this kind of digital twin world. So Seoul already have a 2040 Seoul plan that is a 20-year long history plan inside this we are making the models, creating and testing scenario-based templates. So you can expect AI-based to be done in this virtual world that is the twin of the physical world. So it is the end of my presentation. Thank you.
Thank you for your presentation and your insights. Now, I'm pleased to introduce our second speaker of the day, Dr. Yanan Sin. Dr. Sin is an assistant professor at the Department of Transport and Planning at TU Delft in the Netherlands. She also serves as the co-director of Diamond Lab, which stands for Digitalization and AI for Mobility Network Dynamics. Dr. Sin's research is particularly relevant to our discussion today, as she focuses on promoting responsible AI transformation in transportation systems. Her expertise spans several crucial areas, including interpretable machine learning, spatial causal inference, and mobility-based anomaly detection. Before joining TU Delft, she was a senior assistant and lecturer at ETH Zurich. Today, she will present on unboxing AI to assist transportation decision-making, where she will discuss both opportunities and challenges of implementing AI in real-world transportation settings. Dr. Sin, we look forward to your presentation. Please begin.
Thank you very much for the introduction. So today, my talk is on AI for sustainable urban mobility. AI offers many opportunities for promoting sustainability in the transportation field. And it has been utilized in many areas of the transportation system. For example, in traffic management and control, AI can provide us real-time traffic prediction to enable dynamic traffic control. In public transport optimization, AI has also been utilized to predict the demand in advance and help in allocating resources and scheduling of those public transportation systems. And for electric and autonomous vehicles, we all know that autonomous vehicles are built on AI technologies. So as you can see, AI is almost part of our daily operation of various transportation systems nowadays. As we witness the development of AI in the transportation field, there is a strong necessity to improve the interpretability of robustness of AI. This is because transportation applications, many of them are high-stake applications. So it's important for us to make sure that when those applications are deployed in practice, they are reliable. And also, when we use AI to support decision-making, it's important for us to offer the end users with explanation that about the AI models that we use in the decision-making process. The need for enhancing the interpretability and robustness of AI models also aligns with the regulations on AI. For example, the EU's right to an explanation rule or the ethics guidelines for trustworthy AI. To demonstrate the benefits of developing interpretable and robust AI in the transportation field, I will use the traffic forecasting application as an example. Traffic forecasting is crucial in helping reduce congestion and CO2 emissions. And nowadays, AI method has achieved the state-of-the-art performance in traffic forecasting. So we're interested to know what knowledge has the AI model learned from traffic forecasting and whether we could utilize those knowledge to make the AI models more efficient and reliable. So next, I will share a couple of studies we investigated on this topic. The first study focuses on image-based traffic forecasting with UNet models. This case study is inspired by the IRI traffic forecast competition. So in the 3 years of traffic forecast competition, the UNet architecture has achieved the best prediction performance, outperforming other models that have temporal that are considered to be better at capturing the temporal dependencies. So we are interested to know why the UNet model has such a superior performance. To answer that question, we applied different types of gradient-based feature attribution explainable AI method to help us look into those black box AI models. So attribution can be understood as a contribution of pixels in the input feature to a particular prediction in the output. By analyzing the contribution of the input data from both the temporal dimension and spatial dimension, we found out that when looking at the temporal contribution of the input sequences of historical traffic data, contrary to our hypothesis that having a longer historical input data would help in improving the prediction performance, it turns out only the latest historical state help the most in the prediction. So when considering 12 input time steps in total, the previous first 11 time steps historical state only contribute in lowering the prediction error, in this case, mean squared error by 0.6%. This partially explains why a UNet architecture could outperform other models that have stronger ability to learn temporal dependence, because the temporal dependence, especially long-term, camper dependence is not a key contributor to traffic forecasting in this case. When looking at the spatial attribution, we also found out that for a specific target prediction, the neural network only utilized part of the spatial dependencies that correlate with the target traffic flow or speed prediction. It does not utilize the entire scope of pixels or input data that have correlation with the target. This insight also shows that we sometimes could reduce the scope of input data to make the model more efficient and also produce good prediction performance. In the second case study, I want to show you another perspective on utilizing explainable AI method for understanding traffic forecasting models. So the second case study is about counterfactual explanations. The question we want to answer in this case is what input feature, particularly contextual features, contribute most to the traffic forecasting, and what features with minimal change can alter the prediction. So this could help us investigate the sensitivity of the model against the perturbations of input features. And to answer this question, we utilize the counterfactual explanations. The logic behind counterfactual explanations is you have original input features and you fit them into a black box model. You have the original prediction outcome. And now you define an alternative prediction that you would like the model to achieve. For example, increasing the traffic speed during peak hours. And once you set a target prediction, we go back to the input space and change the input features, generate counterfactual features to achieve that alternative prediction. So this allows us to identify the features that with minimal change that can help us alter the prediction to a desired outcome. Why we utilize counterfactual explanations? Because it can help us identify the importance of contextual features. And also, it helps us identify the vulnerability of machine learning models against adversarial attacks, particularly perturbations in the input feature. So I would like to share with you one interesting result from our study. When looking at the counterfactual predictions across different spatial environment, particularly we studied a segment in the suburban road, a segment in the urban road, and a segment in the highway. We realized that by altering the static contextual features, for example, speed limit, number of lanes, and number of point of interest, those features can help us alter the traffic speed to the predefined traffic speed, in this case, 56 kilometers per hour. However, it does not have much influence on altering the traffic speed in highway. So this shows us, although also contrary to our previous belief that contextual features in general contributes to improving traffic forecasting accuracy, in highway, the static contextual features do not help much. But in contrary, those features will have a considerable impact for improving or altering traffic speed in suburban and urban roads. Next, I want to talk about the robustness aspect of AI. So in the third case study is the question is motivated by the need to make AI models more reliable when deployed in practice. Most of the predictive models are trained in using observational data, and evaluated using accuracy. Once we deploy those models in practice, because mobility patterns continuously change, so it's very common for us to observe data distribution shifts. In this case, the model that used to work in training may not work anymore. So we propose that Beyond the accuracy evaluation, we also should evaluate the robustness of those models, particularly against distribution shift before deploying them in practice. And to achieve this, we proposed a robustness benchmarking framework. This framework consists of four components. First, we start with a mechanistic mobility simulator and build causal graphs and causal models based on those mechanistic mobility simulators. With these causal graphs, we could conduct causal interventions to generate controlled interventional data with no distribution shifts. And those interventional data could help us evaluate the robustness of different black box machine learning models. We also integrated this robustness benchmarking framework with the Open Digital Twin platform, which helps to provide a user-friendly interface, particularly to empower domain experts and policymakers to utilize this robustness framework. This Open Digital Twin platform can also support traceability, reusability, inspection, and querying of specific functions. And considering some of the mobility data are sensitive data, through this integration, it can also support access control for sensitive data. So with this, I conclude my talk. Thank you.
Thank you for the great talk from Rian Xin. And we have next speaker, Dr. Franklin van Vincent. Dr. Franklin, who leads AI solution development at Vale, a Luxembourg-based company specialized in environmental analytics. With his expertise in data science and remote sensing, he focuses on leveraging satellite data and AI to create practical environmental solutions. Dr. Van Vincent holds a PhD in applied biological sciences, and he has spent the past 6 years applying deep learning to Earth observation data, helping cities make informed decisions about environmental management. Today, he will present on harnessing satellite data and AI for urban resilience, showing us how this technology can help cities address climate challenges and other urban issues. Dr. Van Vincent, please begin your presentation. I think we are muted.
Is that better?
That
Yes.
is slightly better. Hi, Franklin. Yeah, and we could see your presentation in full screen mode earlier, but now we can see it with the notes. So if you could go back to the other.
Yes, sorry for that.
No, that's okay. We can still see all the slides.
It works like this?
No, we can still see all the slides on the left-hand side. Can you go to slideshow perhaps and click start? Or to the bottom right-hand corner for the presentation mode.
Yes. If it's okay with you, I will do it like this. That's good.
Okay, yeah, I mean,
Yeah.
if you could perhaps increase the size of your screen so that we can see it a bit better. Thank you.
All right. So, sorry for that. Thank you very much for the nice introduction. And what do you see? Do you see my notes as well or not? just want to make clear, do you see only my PowerPoints or do you also see the Word
We
document?
we don't see the notes, we just see the slides, all of the slides on the left-hand side with the slide that you're presenting as well.
Yeah. I'll go to it. All right. Again, thanks for that introduction. As you said, I'm the head of development at Rio, Luxembourg-based startup. And we indeed leverage AI and big Earth data, mainly open source satellite data, to create maps and indicators that drive environmental analytics and that help our clients with their environmental management. So our clients are mainly municipalities and other local and national governments. And we also have some private sector clients. And in my role as AI lead, I'm overseeing this development of AI algorithms at the company. That's mainly computer vision models, work a lot with convolutional neural networks. And I've been doing this in the past 3 years for Rio, but also before for different startup Earth Lab. And with that experience, in the next 10 minutes, I would be happy to share a bit about how I think that cities can and then should use satellite data for promoting urban resilience, especially in the face of climate change. So let me start by speaking a little bit about satellite data. So Jan, the previous speaker, already showed some examples of using spatial data. And indeed, satellite for Earth observation has been used since around the mid of the previous century, so since the 1950s. In the beginning, mainly for meteorological and atmospheric monitoring, but since the 70s, the NASA launched the Landsat program for land monitoring that includes urban landscapes. Europe was a bit behind. They launched the Copernicus program together with the European Space Agency and the Commission, and the Sentinel missions starting in the 2010s. But they now have a very, very good, openly and freely available Earth observation program. And the fact that it's openly available, including for commercial use, really make a change because, well, of course, it made Earth observation widely available and it was an enormous boost for this downstream sector. And in the recent decades, we also seen an enormous launch of commercial satellites. This is because of the technology, mainly the CubeSats, so the smaller sensors, small satellites, but also because of the cheaper launches, made it affordable for commercial satellites to launch. And actually now in the last decade, the number of commercial satellites outnumber the public satellites. And I believe that Planet alone has about 300 satellites in orbit. So with that, there is a global coverage, and there's also a very high revisit, so a very high frequency of this coverage. And it means also that there is an enormous volume and velocity of data. The new data is into the hundreds of terabytes per day. And that, of course, makes the total amount of historical data available into the petabyte scale, which also means that this is a huge opportunity for machine learning. And indeed, now the largest challenge is no longer images availability, but it's more the ground truthing or the labels for both training and validation of these remote sensing models. And apart from this big volume and velocity, there's also a big variety of different types of sensors. So there's the optical imagery, which consists of the offering of Landsat and the Sentinel-2 program. And this is not just the optical lights that we can see, the visible spectrum, which is the red, green, and blue like in your camera, and also how we perceive images. But this extends into the infrared and the thermal wavelengths of the electromagnetic spectrum. And we have now multispectral and hyperspectral data available with hundreds of bands within the spectrum available. And then there's also active remote sensing that, unlike the optical sensors that use reflectance of the visible light, the sun, they use instead radio waves. And that has the advantage that they can look through clouds during the nighttime. So this richness in different types of data, and the fact that this data is very scalable and also to a large extent quite unbiased, provides a very good case study for monitoring urban landscapes. So also this high revisits ensures that you can have consistent monitoring and track changes over time, quite precise, which allows urban planners, for example, to monitor the pace of urban sprawl, urban development over time, identify high growth zones, etc. SAR data, so that's synthetic capture radar, which can capture also through clouds, has been widely used in flood assessments in cities, specifically for pluvial floods, where clouds would hinder the other remote sensing means. And we can also, for example, monitor sealed surfaces, which then can be used as an input for flood models. Disaster relief satellites is also used to understand what are the vulnerable zones within cities, or even mapping available routes to the vulnerable zones. And one of our main products at Rio, that's another case study, that is our green monitor, where we monitor urban green spaces and, for example, the growth and health of vegetation, which helps in prioritizing urban green management. So before this, and it's still the case, for example, in Paris, arborists, they are having an iPad in the hand, going to all of the different city trees, taking notes on the health of and the growth of each individual tree. And now we can give the same amount of data on a very, very frequent basis, and instead of doing door-to-door, in this case tree-to-tree service, which normally only happen once a year. If already once a year, we can do this at multi-scale and multi times a year. And then, of course, also the global coverage eliminates biases that are associated with ground-based sensors, and allows to compare different municipalities across the globe, for example. We can also monitor things like green roofs, existing or potential for green roofs. We can relate this to air quality, for example, and then, of course, also we can look into the urban heat island effect. So we all know the urban heat island effect, the fact that, of course, cities are warmer than the surrounding rural areas, and this has different causes. There is the fact that cities, asphalt, concrete buildings, they absorb rather than reflect heat, and they have a high thermal storage capacity, so reflect this throughout the day and throughout the end of the night. Then there's also the fact that within cities there is less vegetation, that has a natural cooling effect through shading and evapotranspiration. And then there are some anthropogenic heat sources like air conditioning, but also buildings, industrial facilities, vehicles even, that contribute to warming cities. And like I said, urban heat is particularly a problem at night because of these cements, asphalts absorb heat and then slowly release their heat when the sun goes down. This has led to seriously health-related issues such as respiratory difficulties, exhaustion, but even in severe cases, death. And in fact, in a recent study in Europe, it was shown that in 2022, I think 61,000 people in Europe, deaths were caused by heat-related issues. There's also a socioeconomic aspect to this story, because poorer neighborhoods are usually more exposed to heat exposure because lack of air conditioning, but also often because there's less green in these neighborhoods, and which the climate change, we are expecting to have increased frequency and also intensity of heat waves. So this is a major concern to cities. And one obvious aspect that they're thinking about as a solution is greening. So, for example, Paris is planning to plant trees and have 50% canopy cover by the end of 2030. And then satellite data can definitely help in assessing where to plant and to also monitor this vegetation. So at Rio, we provide different layers, maps of urban green spaces. This is individual trees, mapping individual trees, but also going into not only public parks, but also private gardens and green roofs. This is data that's not always easy to obtain for municipalities. And then we can track and set the growth and the health of this vegetation. So that we can then also correlate to temperature. We can make heat maps where we can capture twice a day, every day, the day and night temperature at the 10-meter resolution. So that means we can identify neighborhoods that are, or even streets that are more at risk, and then relate that to the greening in that neighborhood. So indeed, from a study, it shows that in cities, the hottest spots are usually having less than 6% vegetation cover, and then the coolest spots has over 70% vegetation cover. So city officials can use this information to identify the areas that are most at risk, and then they can prioritize the planning of trees, other green infrastructure in these areas to help cool down the urban environment, optimize also building materials, and design the city to reflect heat, optimizing the urban layouts, or even think about enhancing ventilating corridors. To a certain extent, also the historical perspective is important in this, and is a key advantage of satellite data, because it allows us to look back in time, and that's essential for projects focused on long-term analysis. For example, for identifying trends, and then urban planners can analyze historical data to trace the development of urban heat islands over the years and implement more effective strategies, and even investigate climate change scenarios and compare that to current conditions.
Dr. Van Vincent, could you wrap up in 2 minutes?
Yes, okay. So I just want to wrap up showing a few more examples of the maps that we create, and speak maybe also a little about the downside. So the downside, we mainly use open source satellite data, and the downside there is usually the resolution. In general, with remote sensing, there is a resolution issue potentially. So we try to tackle this by things like super resolution, unmixing at the pixel level, and of course we can combine it with in situ sensors. So just to wrap up, I think there's a lot of opportunities. There's a lot of new technologies coming on, like hyperspectral data, that allows us to even better unmix at the subpixel level different materials, like different types of roof materials, or even different types of backfill. So I think I'm very excited about these coming opportunities. And I guess with that, I'd like to thank you very much for this opportunity to speak here. Thank you.
Thank you for your presentation. Okay, our next speaker is Dr. Shin Koseki, who holds the UNESCO chair in urban landscape at the University of Montreal. He will present the role of cities in responsible AI governance. His presentation has been recorded, so let's turn to his presentation.
Shin Koseki, I'm an assistant professor at the University of Montreal, and I'm a holder of the UNESCO chair in urban landscape. I'm also a member of MILA, the Quebec Institute for AI. And my presentation today, unfortunately, I cannot be there with you. I'm currently sleeping or on a plane. So thank you very much, Ike, for having me, for inviting me to this event. I will talk about some of the work that we've been doing at the UNESCO Chair and at Mila for the past few years, focusing on what are the risks of AI in cities and how we can harness and address those risks with better governance, but also with a more inclusive development of the algorithms. So basically, this is something that we've been working on since 2017. Before actually I joined the chair, I was a researcher, a PhD student, and then postdoc in different universities in Switzerland and also in different countries in Europe and in Asia. My name is Shin Koseki. I'm an assistant professor at the University of Montreal, and I'm a holder that we've been doing at the UNESCO Chair and at Mila for the past few years, focusing on what are the risks of AI in cities and how we can countries in Europe. And basically, this is something that we've been working on since 2017. Before actually I joined the chair, I was a researcher, a PhD student, and then postdoc in different universities in Switzerland and also in different countries in Europe and in Asia. And overall,
Hi, Inyong. Sorry you stopped sharing, but the video was running smoothly.
Okay. Sorry about this.
Perfect.
Let's go back to
what are the impact of AI in cities and how to better govern those impacts, as well as how to create algorithms that might be more responsible, more inclusive, and that might hold less biases towards the people that are the most vulnerable to this new technology. The objective of the presentation today will be to look at how we can apprehend the deployment of AI in cities through responsible governance and development. And I want to emphasize on this word apprehend, which can mean both understand, fear, and control. The structure of the presentation is very simple. I will talk about what is AI and how we address it, how we govern it, and how we develop it. So, the first thing to know is, why do we need to do this work? As you know, AI is a very disruptive technology. A lot of people have been raising red flags about its potential impacts on humankind and the environment. There's been a call for a moratorium to stop the development of certain AI that came both from the industry, but also from researchers and from different influential people around the world, including our dear Elon Musk. AI is first a social project, and my first relationship to AI was this character played by Arnold Schwarzenegger in the movie Terminator. So most of you might have seen this movie. Of course, back then I didn't realize the character, who was a robot, was trying to portray this kind of idyllic vision of what AI could become in the near future, but also the most non-idyllic version of what it can become. AI is also an expensive technology. It's been around for quite a few years now. The concept itself has evolved from its first use in the 1950s all the way to today, with different kind of milestones, such as when AI first won against the grandmaster at chess, or the launch of ChatGPT and other generative AI algorithms. AI can also be understood as a multi-layered concept. So basically, how we look at AI can be, taken from the perspective of the data that we are using to train the algorithm, but also the algorithms themselves, how they are being embedded in what we call artificial intelligence systems, and those systems that included in applications that we use on a daily basis through a series of utilization that we make ourselves. AI is also an industry of knowledge with a lot of major actors that have been around for quite a few years, that have kind of progressively or radically changed their business model to fit this new technology, such as Google, Meta, Amazon, Microsoft, and so on. Also some new players such as OpenAI, and research and academic actors such as the Turing Institute in London, Mila in Montreal, the FIRE in Brussels, the MIT CCEL in Boston, and also a series of governmental or paragovernmental agencies that both kind of like look at what are the impacts of AI in society, but also how to promote it and how to facilitate its use by both the people and by the industry. And finally, AI can be understood as a life cycle, and this is how we actually address it. So basically looking at how the technology itself is being developed into different phases, starting with framing, for example, then design, implementation, deployment, and maintenance, and how every step of this process kind of introduces new biases and new risk to the technology, and how we can address those biases and those risks. As I said, one of the major issues with AI is the inherent biases. If we try to generate images of toys in the US versus toys in Iraq using generative AI today, what we see is that those models are aligned with the biases that are inherent to the data and that might have been introduced later on in the life cycle process, where we have these kind of cultural deformation associating countries with different social and political contexts. AI is also insidious and omnipresent. It's basically everywhere, and it's getting, in more places. It's in the military, it's in the use of Prime or Netflix, it's on our smartphone, it's in our research, of course, in the transportation that we use, and even in toys and language correctors. And one of the big issues with this is that AI is, deeply unregulated. So basically, it is one of the most unregulated technology today, with only one legal framework being in place right now, which is the EU AI Act, which still has to be kind of like, fully implemented. Otherwise, what we see is that countries are really reluctant in engaging in regulating AI. The most recent example was, of course, the veto by Governor Gavin Newsom of California on the California AI Act, which basically killed the project just after it was voted by the representatives. And this is a problem, or these are problems that we've been trying to address in a series of tracks at the Applied Machine Learning Days since 2018, working with, for example, EK on this. We've tried to gather a bunch of different people from different perspectives and different expertise, researchers, thinkers, politicians, AI makers, and so on, to kind of understand what are the actual implications of AI for cities. And basically, by the way, the next edition of this is in February of next year, and we hope for those who live in Switzerland or can come to Lausanne that you'll be there. And I'm going to stay in the call, yes. Back in 2021, so Mila was approached by UN Habitat to create this framework, which is called AI in Cities, Risk Applications and Governance, which is actually derived from the series of tracks that we've been organizing. UN Habitat is the UN agency for cities and human settlements, and they basically oversee issues relating to human rights, sanitation, transportation, equity, diversity in cities and human settlements across the world. And so we came up with this kind of like very accessible, simple framework that kind of address the major issues on using AI within and by cities nowadays across the world, right? And this kind of booklet divides into 3 parts: one on applications, one on risk framework, and one on the strategies that cities can put in place to kind of reduce the risks introduced by the technology. So on the application part, we kind of took a very generic sectoral division of cities, looking at energy, mobility, public safety, water and waste management, urban planning, and city governance. And what we did is that we tried to, for each sector, illustrate a series of ongoing or upcoming applications, and also provide some context, especially for those applications that we deem the most problematic, such as, for example, predictive policing. Then the risk framework, as I mentioned earlier, tried to identify what are the risks that every step of the AI lifecycle kind of holds into, and how we can address those risks through different practices and by asking ourselves different questions. And finally, the urban AI strategy part actually exposes a series of concepts and principles and ways of doing that cities could and should embrace in order to reduce the risk of AI on their population and onto the environment, such as starting from the local context, prioritizing capacity building, and fostering cross-sectoral collaboration. And this is actually what we're doing also at the chair and at Mila when we try to develop our own AI algorithm for cities. So we take an approach that is both based on the AI in Cities white paper, but also on the Montreal Declaration for Responsible AI, which was created here at the University of Montreal. And we apply it by a series of strategies, such as, again, participatory conception, so working with the people, with citizens to define, the framing, design, implementation, deployment, and maintenance of algorithms, by working in intersectoral manner, so working across computer sciences, but also with social sciences, philosophy, art, and so on, and by focusing on underprivileged individuals who are more at risk of dealing with issues related to AI. And this brings us to the last part of my presentation, which is where I'm going to present very briefly two projects that we've been working on for the past year or two. The first one, called Eveline, its goal was to measure the quality of public space using a participatory and local AI. So, back in 2022, we were right during or after the pandemic, and what urban researchers saw is that people who come from underprivileged groups or marginalized individuals, especially those coming from underrepresented ethnic, cultural, and religious minorities, also LGBTQ people living with disabilities, and women, had a much lower access to public space at a moment where it was the most needed, so during the global lockdown. And one of the reasons for this is because cities are inherently structurally unequally accessible to people and tend to favor dominant groups. So to address this, what we did is that we partnered up with a bunch of different local organizations here in Montreal, working with underrepresented individuals, and we tried to create a series of algorithms that that can understand what makes public space good or livable or playful or beautiful from the perspective of those different groups. And the idea here is that it's a project we still continue working on, but the idea here is to eventually be able to map those qualities across very large urban territories, such as Montreal metropolitan region, but also perhaps test it in other cultural contexts and see which spaces are the most, let's say, problematic from the perspective of those underrepresented groups. A second project that we've been working on here, the development of participatory and local AI that is capable of aligning generative AI images of public space for more inclusion. So again, what we saw from our research is that a lot of generative AI tends to integrate biases, social and cultural biases within its data that is then reproduced and amplified in the images of public space it creates, right? This is a problem that has been long studied. And what we do here is that we partner up with local organizations here in Montreal, working with people from underrepresented communities. And with them, we try to create this series of alignment algorithm that can correct existing open source or openly accessible algorithms to create images in order to see if we can realign or redefine their outputs to fit those people's aspiration a bit closer, right? So if you look at the bottom, we have a series of images. One is prior to fine-tuning, one is post fine-tuning, and a third one is post full fine-tuning. And what happens here is that our algorithms integrates the feedback from those underrepresented groups based on the series of workshops that we've done with them, and corrects or steers the production of images towards what those groups might have wanted or expected. So it's in a sense creating this kind of like positive bias towards underrepresented groups. And to conclude, a few basic principles on how to create an AI in cities for good. Well, first, conceive AI strategies that are adapted to your context, so work locally, especially with local population, local organizations. Start small and try to build things from scratch. Develop an inclusive network with citizens and interstructural actors, especially bridging between, let's say, engineering and social sciences, but also with industry and civil society and so on. Build capacities on AI across urban contexts. So really try to promote a knowledge on AI, in citizens, in researchers, in students, in colleagues, in city professionals and politicians. And finally, deploy AI systems created with marginalized group. And this is something that we're becoming pretty good at. So really working with people that come from underprivileged context or people who belong to a marginalized group actually enhances the chance that the AI that we create does not represent a risk for those people. So on this, thank you very much. I hope you enjoyed this presentation. Unfortunately, I'm not here, but I'm always reachable by email. So please feel free to write to me. Thank you.
Thank you for his talk. So we had multiple presentations for the topic, and now we have a discussion session. So we can explore the implications of today's presentations and dig deeper into the challenges and opportunities of AI in urban development. I'm delighted to introduce our two discussants who brings valuable perspectives to this conversation. First, we have Carolina Ziba-Kulawik, a research associate at Liger, who brings expertise in remote sensing and AI applications in urban environmental studies. Her work on integration new technology for analyzing cityscape changes and also urban forestry monitoring offers valuable insights into practical implementation of AI. And following her, we'll hear from Dr. Jung-Hyun Woo, assistant professor at the University of Seoul, whose work bridges data-driven urban planning with the value-based urban design. Her research on sustainable urban processes with empirical methods in spatial network analysis will help us understand the human-centered aspects of AI implementation in cities. So Dr. Ziba-Kulawik, please share your thoughts on today's presentation.
Yes, hello. Thank you for your today presentation. This was really insightful. And as I am landscape architect and GIS scientist working on housing and greenery, I would like to add a brief, maybe more general comments to the discussion if we are talking about the sustainable urbanization for good. Because I think it can mean the different things depending on the specific urban context, as cities face different challenges, of course, based on this size, geography, economics development, and environment and other. And while the main goal is to create the cities that are resilient and inclusive, with the access to affordable housing for all, and of course environmentally and climate friendly. The way to achieve this depends on the unique urban settings. And as presented today, efforts are being carried out in many fields, including the remote sensing to provide the specific data and products, which is great and very, very helpful for the cities. And what is new in the urban studies, it is the integration of AI tools, and it still raises many concerns and questions. But I will see that this progress and indeed this revolution, we can say, I think we can no longer stop. And the real question now is maybe how do we guide it and which direction we choose to steer it. And of course, as long as we also mean academia and the private sector, not just the political actors and political environment. Because as you know, the technology is one thing and the applications in everyday life is another. And sustainable urbanization is only a smart part of the application on these new technologies. But it allows us to see the possibilities and the risks that come with AI. I would like to share with you a specific housing-related issue that has already happened in the world. There was a case in San Francisco where property owners use the software and AI algorithms to gain more money by increasing prices of the houses and flats, even if it meant that some of the flats were vacant. So, of course, this use of technology is directly conflicting with the idea of sustainability. And we need to be aware that AI can also be used to damage for example, the property market with, in this case, with negative impact on housing and on people. But the fact is that the potential of this technology is here. We use it on a daily basis. We're creating new products that would be maybe labor intensive or maybe impossible without AI. And I believe that the awareness of the hazard will make us better prepared, and being prepared will allow us to avoid these problems. And this is my hope. This is my real hope. And maybe if we have a time, I would like to ask one general question to our presenters. If we have a time, Ika?
Yeah, I think we have a time. And
okay.
We can extend the 5 minutes.
Yeah, okay. So maybe the quick, more general question, because we see that the cities increasingly become a focal point to the technological innovation. And the question arises, where should urban centers begin developing and implementing these AI strategies? It is such more general question where you can refer to the specific thematic area of your interest, or yeah. I don't indicate who should answer, but
okay.
Yeah.
So any speakers wants to address this question? Or Carolina, did you have any specific question to specific topic?
The specific, maybe not. Maybe another general question: how, maybe how and can and should academia and industry and governments collaborate to ensure that these smart cities remain human-centered and sustainable-driven? Maybe the other question.
Okay. Thank you. Any speakers want to address this?
I can maybe say a few things how we do that. And what we see is that many of the municipalities that we work with, they do have, they're just starting with AI, right? So they do have, to a certain extent, a GIS department, and they do usually want to have a kind of base input layer to that and work with it themselves. But often, or the AI part, it goes with announcing the information on a satellite image in our case. They ask that to be done, right? So we deliver that to them. And it's hard for them still to do it themselves and even sometimes to understand that. So in communicating with them, we spend some time to explain what are the limitations of the AI. And yeah, I think it will depend city by city. We are working mainly with municipalities in Luxembourg, also with the larger municipalities in Luxembourg, but those are not, the cities that probably will have a lot of capabilities themselves.
And in Luxembourg, you have the good experience with the contact with the ministry or some administration unit with this? Yeah, okay.
Yeah, so we also work with the ministry, the Ministry of Environment, for example, delivering similar products. I think for the moment, it has been the same as with the municipality. So the ministry definitely has a good GIS department. We deliver maps to them. But again, the AI aspect is probably they are working on it internally, but they often ask us to do that.
Yeah, okay, thanks.
Our services.
Okay, thank you for sharing your thoughts. Dr. Yananshin, do you have any answers?
I think to answer Carolina's question, in short, yes, absolutely. I think we should, as researchers, collaborate with the government agencies and also industry to make sure that the AI progress is going forward in a secure, safe, reliable, and inclusive path. So, because ultimately, the research we produce needs to have the support from policymakers. And also, we want to, ensure that it's consistent with the practical applications or the development from the industry. So one example we are currently working on, our new project that we're working on at TU Delft, is the AI Compass, which is to use AI technology for crowd management. And for that project, we have more than 20 collaborators that includes both government agencies and also industry partners. So the goal is really closely couple the development in the research field with the application and deployment in municipalities and companies. I believe we can benefit both from this integration. If we can better understand the real world problem and prioritize the most critical issues as researchers. And also those municipalities and also companies could benefit from our advanced outcome from research. So I think, if possible, we should always advocate for a close collaboration between the third parties.
Yeah.
Okay, great. So now can we move to Dr. Jung Hyun-woo? Could you share your thoughts on today's presentations?
Yeah, sure. I really thanks to the speakers today. It's very insightful presentation. So I can say the three the points after listening all this kind of presentations today. First thing is that I think the AI technology can pursue the value of customization. because AI technology can even analyze user emotion through text, voice, or facial expressions, or also providing appropriate responses throughout all this kind of data, personal data, let's say. And leveraging this kind of AI capabilities, I think it is possible that urban environments and designs can reflect the individual preferences and characteristics, including unique personal identities, and those kind of values can be achievable. So I think AI technology can contribute value of each person's the preferences and characteristics. And my second point is that AI technology also can pursue of more diversity as a core value. For example, the varieties of mode of transportation can expand the broader range of consumers and the audience, and increase the overall satisfactions as well. For example, the emerging of autonomous vehicles or robot taxis might initially seem like competition for traditional car consumers, but in reality, it provides a greater spectrum of choices and accommodating diverse needs and preferences of consumers. So AI technology really help out to make a more diverse city, or diversity can pursue the diversity as a core value in the city. And lastly, I can say that AI technology can be utilized as a negotiation device in urban planning. I think it's really helpful to create a more sustainable, equitable, and inclusive and ethical urban spaces. As we know, the public participation and community engagement process are very essential and very important while we are making a city. So I think AI-powered algorithms can generate numerous design alternatives with diverse characteristics and quantitative evaluation each design alternative's value. So this capability can make the inclusion of broader range of stakeholders and audience. In design process, it is allowing their perspectives to be incorporated in the planning through this algorithm analysis. So I think this kind of approach enhances transparency and fosters collaborative design decision making, and that lead to make a more inclusive and effective urban design results. So those are the three key things what I thought about the AI technology related with the urban planning and design. And here is I have a one common or general question for all speakers. So I'm wondering about the which stage or process of urban planning or design this kind of AI technology can be most powerfully utilized, and why? Because I think there are so many AI related research for urban or for city, but I'm still, I don't think like AI technology can solve everything, not yet. But I just wondering which stage or process of urban planning can be mostly powerfully utilized by AI technology.
Thank you for sharing your thoughts and also some further questions. Due to the time limits, I think if you have a quick answers, then you can answer. But otherwise, I think we can conclude this workshop. So for the closing, I'd like to ask Dr. Junyoung Choi for remarks, and then I can conclude.
Thank you for giving us and audience valuable insight and presentations. So I think the one answer for the Professor Wu's question, the stage, they can be more valuable and insightful, utilizable application, giving us some good impact. I think we also think about the predictive thinking using the AI. In the many industrial domain, we think about the user experience or user interactions using the ChatGPT, the user interactions. But the planning itself, our thinking, our creative thinking, needs some kind of the basic instinct about predictions. So I think the planning stage will be the very powerful stage for applying AI, applying stage. It is my personal opinion. And about the closing remarks, we organized this event with many big support and from the Dr. Kim from Lijo, and many thanks for the Dr. Kim and I think we are as a very various kind of domain and expertise. In the future we need some kind of collaborative AI research to deal with very complex urban issues. And we also Seoul Institute and the Seoul Metropolitan Government organizing some ongoing event with the metropolis, and also I hope to the continued webinar with ITU. But anyway, the issue of the applying or utilizing the digital technology, AI, to planning issue is many things to consider. It's a basic, I think the basic research from the Shin Koseki is very impressive outcomes. Yeah. So in the future, we have to gather together to make some kind of collaborative AI research together. Thank you.
Okay, thank you for your remarks. And I'd like to express our sincere thanks to all speakers for your insightful presentations and our discussion for the thoughtful contribution on the discussion, so we can understand better practical implications of our development. And I believe today's presentation and discussions have highlighted both enormous potential and the responsibility we have in implementing AI for urban development. And I'd like to especially thank to our organizing partners and ITU AI for Good team for making this workshop possible. And thank you all participants and audience who joined us today from around the world. We look forward to continuing these important discussions and collaborations as we work together towards more sustainable and inclusive urban futures. Thank you all and have a wonderful day.
Thank you. Bye.
Thank you.
Thank you. Bye.
Thank you.
Thank you.
Thank you for
Thank you.
participating in today's AI for Good session. We hope you've learned something new, innovative, and engaging in today's event. We now encourage you to continue the conversation on the live video wall in the neural network. Here you can ask questions, like and comment, share links, complete the poll, connect with interesting profiles, or speak one-on-one using the chat and video function. We invite you to explore the lobby, try the smart matching quiz, visit the virtual exhibits, poster boards, the e-shop, and build your personalized AI for Good program. Let's shape the future of AI for Good.
The AI for Good Global Summit aims to bring together industry leaders to try and harness AI to further the UN's development goals in areas like health, climate and sustainability.
How do we govern technologies if we don't yet know their full potential?
The main purpose of this summit is to explore how the AI solutions can help sustainable development.
AI will come to influence almost every aspect of our societies and economies.
AI 治理框架
AI for good.
I would say the most pressing topic at the summit is going to be how do you handle deepfakes, misinformation.
成为 AI for good 的
Cumbre Mundial All for Good. And
The good news is that the future of undetectable deepfakes can be avoided through the development and implementation of robust detection technologies and international standards.
What I've really seen is the fact that we can really affect amazing change, but we have to do this together and we have to do it in collaboration with partners, with organizations, with institutions, and that's what's making me so excited about what AI for Good is all about.
One-third of humanity remains completely offline, excluded from the AI revolution.
Artificial intelligence is changing our world and our lives, and it can turbocharge sustainable development.
So we are the AI generation, and this is our moment, and it's our responsibility to write the next chapter in the great story of humanity and technology.